Wow.
Yes, hello everyone. Hello, can you hear me?
Yeah,
Can anyone hear me?
yeah, yeah.
Okay, so good morning. So please inform me that we are still waiting for them. We want to clock about 50 people before we start. And also, I think this account can. Is that what? Yes, please exercise a bit of patience. We want to get most of your colleagues on board. We don't want the situation whereby you might be in the middle of like the lesson and then people will now come and then be asking questions. I mean, a lot of questions from the previous staff. So please encourage your colleagues to join. We want to block with you. So those leaving, please exercise a bit patience. We'll start in the next 3 minutes. Thank you.
Good morning, everyone.
Yeah, good morning.
Good morning.
Good morning.
Good morning. I hope you all are doing well. We are still expecting about 13.
Good morning, all.
Okay.
Good morning.
Okay, let's get started. Okay.
All right.
Sure.
Okay, today's tutorial will be on rules of derivative. Sarah has done it for you guys yesterday, but a lot of people are still having challenges concerning some of the rules. So we'll try to pass through all of them today and solve some of the questions again. I hope that is okay.
Yes,
Yeah.
sir.
Mm.
Yeah.
Okay, so our first rule of derivative will be on what? Constant derivative. How do we differentiate a constant? And also, how do we differentiate a function f? So to do this, like we all know from SHS, to differentiate a constant is what? If you differentiate a constant, you get what? Zero. That's what I've written here. The moment you differentiate a constant, can you see my cursor? I hope
I
everyone
can
Yes.
can.
see your cursor.
Yeah.
Yes, I can see your cursor.
Okay, all right. So this function is for what? C. The function is C. So C is a constant. If you differentiate a constant, you have what? Zero
Zero.
from SHS. Yeah. And as well, if you differentiate what? S,
X.
you get to 1. That one is the simple one. The way we learned it from what? SHS. But let's see this one. There is an exception to it. The power rule. If you have power rule, that means that you have the S exponent something. Here we have S alone is exponent 1. But the moment you have S of a power n, so it has changed. Can you see here where my cursor is? The moment
Yes,
you
please.
have S to the power n, how to the derivative of function. Please mute your mic. Okay, sorry for that. Now, if you have S to the power n, you can see that what from SHS they taught us that what if you want to differentiate a function S to the power n, you have to subtract 1 from the power and multiply the function by what the power itself. That's what we've done here. You can see that you have S to the power n. So it will become what? N S to the power what? N minus 1, which is here. Can you say it? That just like the way you SHS. So now let's apply the power rule, the constant rule, and what? The function S rule in this example. You can see that this example that we have here, f of s is equal to what? Negative 7s squared plus 2 over s cubed minus root square of s plus what? Pi. In this example, you can see that what? You have the power rule here, which is what? 7s squared. You have what? The constant rule, which is what? Pi here. Then you have as well what? The function s rule as well. So for this example, to solve this example now, we'll have to what? Break some of the items in what? In a polynomial form. Because you can see that in this function, we have what? 2 over what? S cubed, which is a fraction here. But we can still write this function as what? A normal S function in form of what? Power rule. And this one too, we can still break these square roots here to have what? S exponent what? Half. So here it is. To solve the function f of s, you have what? Negative s square. You differentiate this one, you differentiate this one too as well, and you differentiate this one all together. So you can see here that we have what? A power rule here. If you apply the power rule here, you have what? 7 times what? 2. Negative 7 times 2 into brackets s exponent what? 2 minus 1. You get it? So that's what we've done, and we got what? Negative 14s here. Negative 7 times 2 will give you a negative 14. And now 2 minus 1 will give you what? 1. And you have what? S exponent 1. So you did the same thing for this one too as well. This function was what? 2 over what? S cubed. But the S cubed now, 2 over s cubed. This s cubed, if you want to bring the s cubed at the top, it will become what? Negative 3, right? So that's what we apply here. We have 2 exponents on negative 3, and you differentiate it 2 as well, and you get this function. We are just applying the power rule. So you do it for all of them, and here you apply what? Constant rule. So the constant rule, you see that if you differentiate a constant, pi is a, and so on. So if you differentiate a constant, you get what? 0. And you just, the remaining things is what? Subtraction and addition. So, so if you do it, the 0 will go, then you have what? 14 minus 14s minus 6s exponent negative 4 minus half of s exponent negative half plus what? 0. Now you have what? Minus 6s exponent negative 4 and half s exponent negative 5. You can see that indices, you can apply indices here. The base of these two variables are what? The same. You have s here, you have s here, so they have the same base. Is anyone talking? So you can see here that the base are the same. You have what? S and you have S here. So you can apply your indices between these two to become what? 6 minus half into bracket S of what? Negative 4 plus bracket negative half. Then you get what? This function back. You get it? Then that's all. But now let's look at this example. A. F of s is equal to what? 1 over s. This one too is what? Power rule. And this one too is power rule. So let's apply power rule for these two examples here. The first one, you have what? F of s is equal to 1 over s squared. So if you take this function, you reciprocate this function, you have what? S exponent what? Negative 2. Then you use your power rule. Power rule will become what? Negative 2 s negative 2 minus 1, like the way we just said here, where my cursor is, that's the formula for what? Power rule. That's the power rule here. I hope everyone can see the screen. Where my cursor is, this is power rule. So you just apply power rule for this function here. Negative 2s minus 2 minus 1. Then you have this function and you rewrite it. Since you have negative 3, it will become a negative 2 multiplied by what? 1 over what? S exponent 3. And that's all. You do the same for this function too as well. Here you have a square root of s. Square root of s. Square root of s is equal to what? Half. S exponent half. So if you reciprocate it, you have what? S exponent negative half. And you apply the same power rule till the end. Now let's talk about derivative of a sum and derivative of a difference. The sum and the difference, they are the same equation, but the only difference between them is the sign. For the sum, you have what? Positive sign there, and the difference, you have what? Negative sign. So here the theorem is saying that if you have f of s plus g of s prime of s, it will become what? F of s plus g prime of s. And the same thing apply for the derivative of what? A difference. You have f of f minus g into bracket prime of s is equal to what? F prime of s minus g prime of s. So let's solve some example to see how we can apply these equations. Here is the example. If f of s is equal to negative s squared plus 2 over 3 minus square root of s plus pi, like the previous example we saw, you can see that what? First, we apply power rules here all together, but here now we can still apply what? The sum and what? The additions rule and what? The power rule as well. once you are dealing with what a unique function here like this, you use the power rule for this one. Then if you are coming to add the two of them, you use what the sum rule here, and these two you can apply what the subtraction rules here. So for this function, if you apply the power rule, you have what negative 14s, and this one if you apply what your power rule, you get what sorry this place we have s cubed. I'll send you the slide later, you can see it clearly, or you can check in the PDF that have been sent to you, you see the question over there. So this one, if you change the function to become s exponent half, you apply the power rule as well for it, and you get what half s exponent this. So now you have this function down here. So you use this one, you apply what the subtraction rule between these two, between these three here. After applying the sum and the subtraction rule, you have what this one. That's all. So this one becomes your f prime of s, and this one becomes what your g prime of s, according to what the sum rule, f prime of s plus what g prime of s. So if you come here now, you will see that this function here become what your f prime of s, and this one become what your g prime of s. Then you apply the power rule for what this function, and you apply it for this function as well. Here is another example for what subtraction rule. F of s is equal to 4s minus 6. So to apply the subtraction rule for this function, you have what f prime of s is equal to what 4s prime minus what 6 prime. Just like the formula has said here, f prime of s minus what g prime of s here. Then now you take this one, you apply what whether the derivative of s, or you apply what the power rule. If you apply the power rule, you can see that here you have what exponent 1. So it will be what 1 minus 1. 1 minus 1 will give you 0. So you have what s exponent 0. Any number exponent 0 is equal to 1. So you have what 4 times 1, which is equal to what 4. And here you have a constant. So you apply what a constant rule here. If you differentiate a constant, you have what 0. Then you have what your 0 here. 4 plus what 0 will give you what 0. Whether negative 0 or positive 0 is still 0. That's why the sign still, we just put the positive sign here, even though here is negative. So your answer will be 4. Now let's move to another form of derivative, which is what the product derivative and what the quotient one. This is where a lot of people get it wrong. For the product rule, no matter how you do, no matter which function you bring first, will still give you the final answer. But if you are dealing with the quotient rule, for example, you must make sure that if you are differentiate a function that is a quotient rule, make sure that you bring the function at the down first, which is what g of s first, before you differentiate the top, which is s prime of s minus what f of s times what g prime of s, all divided by what g of s squared. In a situation where you do here f prime of s multiplied by g of s, in some cases it will work for you, but in other cases it will not work. So you must make sure that what when you are dealing with product rule is what g of s multiplied by f prime of s minus f of s multiplied by g prime of s, all divided by what g of s squared. But for the product, you what the same answer. Multiplication is what commutative. So you have f of s for d dot for f dot d prime of s, you have what f of s g prime of s plus what plus g of s f prime of s. Now let's try to solve some example and see how we can apply these two derivative form. Let's take this example. If g of s is equal to cubic root of s plus 5 into bracket, another bracket open, s cubed minus 6s, what will be our g prime of s? Our g prime of s will be then cubic root of what? This one first, the cubic root of s plus what? 5. You keep it constant, you don't differentiate this one, then you come and you differentiate the next one, which is what? S cubed minus what? 6s prime. You differentiate this one, then plus s cubed minus 6s into bracket. You keep this one constant now. So you can see that this one and this, they are the same. You keep this one constant, then you differentiate what? The first one, which is what? Cubic root of s plus 5 times. So after you do that, now you can expand these two and expand these two and cancel this out. After you cancel this out, you have the same this. You apply your indices here again. You have what? Exponent 7 over 3 here. You have exponent 7 over 3 here. So this one and this, you can put them together and you factorize your equation and you raise here. Now let's try to solve one with what? The quotient rule. The quotient rule too, like I told you, anytime you are starting, make sure that you start with the down one first. You keep the down one constant and you start with the down one. If you don't do that, your answer will be what? Wrong in some cases. So you can see that here we have s cubed plus 2 at the down. So we keep down one constant first and we differentiate the top, then we subtract it what? From the other one. We keep the top of one constant and we differentiate the top one, all divided by what? Your top. Please, am I going too fast? Hello?
Yes, please.
Please, am I going too fast?
Yes, please.
Okay, sorry for that. So I'll go slow for you guys.
Can
Okay?
you please go back to the
Product rule.
Yes, please.
Hello? Hello?
Hello.
Hi.
Hello. Hi.
Yeah. Someone was
A moment, please. We'll be right back.
Calvin.
Odogu, please, your camera is on. Oh. I beg, quench out.
Hello, everyone. Sorry for that. My network is not stable, but let's wrap up fast and we'll see how we can go. But don't worry, I'll try to go as slow as much as possible. Someone was asking me to uh,
Yes, please. Please go over it for me.
someone was asking me to go back to product role. So for the product rule, the thing is that you have D, here is D dot F prime of S will be equal to what? What you do here is that you take F and you find they will give you two functions. You get it? You have two functions, not necessarily F of F and G of S, but they can give you, for example, like a function like S squared minus 1 into bracket and another bracket S plus 3, for example. So you consider one of the function into bracket as what your F and the other one as what your G. Then the two function, you keep the first function intact. You don't do anything to it. Then the second one, which is what, for example, your G of S, you differentiate that one. Then you add it to what? The G of S, and you multiply by what? The first one, the derivative of the first one. But like I said, make sure that as for the product rule, whether you bring the G constant first and you differentiate the first function first, it doesn't matter much because we know that multiplication is what? Commutative. But if you are dealing with what? The quotient rule, this is where the challenge comes. Anytime you are dealing with what? The quotient rule, you have what? One function at the top and another function at the down. Then you take the function at the down first, you keep it intact, you don't do anything to it. Then you multiply it by what? The derivative of the function at the top, which is what? F prime of S. And you subtract what? Now you keep the top one constant, which is F of S, and you differentiate what? The down one, and you divide all by what? twice, you multiply d of s times what? D of s, which is what? D of s squared. So the example for the product rule is this. This become what? The cubic of s plus 5 is what? Now your f of s. And this one is now what? Your d of s. The s cubed minus 6s is what? Your d of s. But here, like I said, the product rule, whether you keep this one constant and you different this one first before you bring this one, it doesn't matter. So you see that here now I just keep this one constant. S cubic root of s plus 5. I keep this one constant and then they differentiate this one. Then you add up to what? The second one. You keep this one now constant and you differentiate this one. So after doing that, the only thing remaining now is what you apply what? Whether the power rule or what? The constant rule or what? Yeah, or what? The S derivative rule. So you can see here that what? If you want to differentiate this one now, if you use power rule for S cubed, you have what? 3s of what? 3 minus 1, which is equal to 2. But here you just apply what? The derivative of S, which is what? S minus 1 exponent here, and you have what? 1. 6 times 1 is what? 6. Then the second one to do same for what? The second one to you expand it. After expansion, you can see here that what? We have 3s exponent what? 7 over 3. But here you have what? 1 over 3 s exponent 7 over 3. So what I was saying is that for this function here and this function here, you can use indices between the two. The base are the same. You have s here, you have s here. So you can apply your indices here. Since the base are the same, it will become what? S exponent what? 7 over 3 plus what? 7 over 3. Then these two, 7 over 3 into bracket 3 plus what? 1 over 3. Then if you do it, you get what? 10 over 3 exponent what? 7 over 3 here. Between these two, this one here and this one here, you just apply indices in between the two. Then you get what? This one here. As for this one and this one too, for this one, what I'm saying is that where you have negative 6s exponent 1 over 3 and what? And negative what I'm saying is that when we have negative 6s exponent 1 over 3 and what? Negative 2s 1 over 3 exponent 1 over 3 here, you can still apply what? Indices between these two function, the one I just mentioned. So if you're applying indices in between, then you have what? Into bracket negative 6 minus what? 2 bracket close s exponent what? 1 over 3. Then you get what? Negative 6 and negative 2 will give you what? Negative 8, which is what? The negative 8 exponent what? S 1 over 3 we got here. And then the 30 is a constant that we got, we just replace it. This one too is the same, you replace it here. So it's only in between 3s exponent 7 over 3 and what? 1 over 3s exponent 7 over 3 that you apply indices between this one and negative 6, 1 exponent 1 over 3 and negative 2s exponent 1 over 3. You apply indices between the two as well to get this one. Then your final answer will be what? 10 divided by 3 s exponent 7 over 3 plus 15 s exponent 2 minus 8 s exponent 1 over 3 minus 30. That's your final answer for the product rule example. Now, let's talk about the quotient rule example. The quotient rule said that if you have h prime or f times, if you have f divided by d of s prime of s, you have what? D of s into bracket f prime of s minus f of s d prime of s, all divided by what? D of s square. This is the quotient rule. That's what I just mentioned right now. So let's apply this rule for our example. The function given to us in this example is what? H of s is equal to what? 1 minus 3s squared divided by s cubed plus 2. So how can we apply the quotient rule for this function? We take the down to be what? Our d of s, and the top to be what? Our f of s, like is shown in this equation here. Now, d of s here is s cubed plus 2. So for quotient rule, I said you start with what? The down one. So you keep the down one constant. So here we keep it s cubed plus 2 constant. We are not differentiating this one. Then we differentiate the top. We multiply by the differentiation of the top, which is what? 1 minus 3s squared prime minus. Now, you keep the top constant. The top is here is what? 1 minus 3s squared. You keep it constant. Then you differentiate the down. The down is what? S cubed plus 2. Then if you differentiate that one, you get what? 3s squared. But like the product rule said, you have the down to be your d of s squared. So now, your down here is what? S cubed plus 2, which is your d of s. You just have to square it. Or you do s cubed plus 2 multiplied by s cubed plus 2, which is what? S cubed plus 2 all square. And now, the remaining things for you is what? To expand. You expand the top one, then you simplify things out, and you get your final answer. We want the answer to be what? In the simplest form. Okay? Now, let me give you one point. It may seem for you that what all that you are doing right now is quite simple, so you can just rush. But here, we'll be more interested in the steps. So if you are solving this thing, they ask you that use the product rule to find this thing, or use the quotient rule to find the derivative of this function. Make sure that what you do it step by step. Don't just jump steps. Do it step by step. You can see that here we try to write the equation first by putting the prime and the prime at their right places. Where the square will be, we put it there too as well. Just like the way it's looking in the equation here, the actual equation. So you do the same thing for this one too as well. Don't jump this step. If you jump these steps, you are losing math. After these steps, then you come here, you can use your other rule, which is the power rule here. For what? 3s squared, you can use power rule for this one. This one is a constant. You use constant rule for this one. And this one you can use power rule, and this one you can use power rule, and you go. But please and please don't miss the first steps, which will tell us that you are using this equation, and the equation said so. Now, this is another example for the quotient rule. The down here, which is what? S squared plus s plus 5 is what? Our d of s. And the top, that is 2s minus 3, is what? Our f of s. Till you apply the quotient rule, you keep the down constant first. The down is what? S squared plus s plus 5. We keep it constant. Then the top one, we do what? We differentiate the top one. Yes, someone will say that here they just do it direct by writing 2. Yes, because we know that that's how it will go. But if you want to put everything here, it will become too cloudy because we are trying to present it. That's why we try to remove some of our steps. But I told you last tutorial that what never miss a steps. Even in a textbook, they will not show you all the steps, but we expect you to show us all the steps because it's like you are teaching us how to solve the thing. And if you are jumping steps, how are we going to know what you are doing? So please and please, for this one, try to apply the rules like this side, like the first stage here. Try to write this function true like that. If you are having pen and paper with you right now, I would like you guys to try to solve this one for me. Just give me the first steps for this one. Once someone is done, the person can raise his hand or the person can just tell me. Done. The first person will take let's say +2. Okay, 2 is too small. +5 for the person that will give me the correct answer.
Please, I'm done.
Please.
Lenovo or what?
Yeah.
Give me your answer.
So the first step
is that your real name?
No, that's the brand of the laptop.
Okay, give me your name so that if you are taking the 5 points.
Kenneth.
You can send a message to us and we'll get it, okay?
Okay.
Yeah. Give me the answer.
Should I say the answer?
Yeah.
Okay, so the first step will be x bracket open.
Yeah.
X squared plus x plus 5.
Yes.
Bracket close. Another bracket open.
Yes.
2x minus 3 prime.
Yeah. Prime, okay.
Minus
yes.
2x minus 3
okay.
Bracket open.
X squared plus x plus 5 prime.
Okay.
All divided by x squared plus x plus 5 squared.
Okay. You get your +5.
Hello.
All right.
I think we'll be doing it like that.
Hello.
You answer. Yes, hello.
Yeah, please. With the quotient rule,
Yes.
I think if the rule stated is complicated for us, then why then don't we say that okay, we can say dy dx is equal to v du dx minus u dv dx all over v squared, where v is equal to g of x, and then f of x
equal to u of x.
will be equal to u.
Yeah, it's the same thing you are just repeating, like the way the equation show it here. You get it?
Yes. So I think
write it. Yeah, you can still write it like that.
Okay. And then using that
it is you have u over what v prime of s, right? And to become what u of s times what u minus what u of s times what v prime of s all divided by v square, right?
Yes.
Okay, yeah, that's it. You can still do it like that. Just that
Okay.
the understanding and the first step, how to show the steps, we are more interested into that. Okay.
Okay.
But right now you understand, you see that you yourself say you can replace those terms by what he and you. That's
Yeah.
fine.
Yeah.
Okay.
Yeah.
What's the name, please?
All right. Thank you very much.
What's the name?
Mbolakan Isaac.
Isaac.
Yes.
Okay. I see. Oh, give me your ID.
You said
Your ID number.
22
Yes.
05 025.
025
Yes. Then 802.
802. Okay.
Yeah.
Oh, one bonus for you. Please,
All
sorry,
right.
2 bonus for you.
Okay. Thank you.
So this is how you solve the quotient rule. I hope everyone is following.
Yes, we are all following.
Yes,
we are.
please.
Yes, we are all following.
Okay,
Yeah.
thank you. So now let's move to this next week. Let's move to this example to solve it right now. Then let's move to what? The chain rule. This is where some people get it too wrong. The chain rule is a kind of function that if you have the power of the function is very high, that you cannot solve it using what the power rule or those things. It will be very long. Then you use chain rule. Or the chain rule, the other way is that you can just use Pascal rule for what? Big powers. But using Pascal rule it will make the thing very what? Long. So they come up with a way that you can solve it by jumping or some steps, and your work will not look too cloudy, which is what the chain rule. The chain rule is that if you have d of s into bracket f upon d of s, then this function, the differential form of this function here will be what? F prime of what? D of s multiplied by what? D prime of s. So the question is that what is f of s and what is what? G of s. So let's look at this example. Take this example. Y is equal to 1 over 2 s exponent 4 minus 3 exponent 2 minus s plus 5, all into bracket exponent 11. We all can see here that what? The power is high, 11. If you want to do this thing normally, I think you use more than 10 A4 sheets. Because the power is what? If you want to show all the steps, that one I think you use 10 A4 sheets. I show me all the steps. So instead of doing too much work like that, we just have to use what? The chain rule for this function. So the chain rule said that what? F of what? D of s. This is what? Everything here like this is what? Your f of s. But 1 over 2 exponent 4 minus 3s squared minus s plus 5. This one alone inside the bracket is your g of s. But everything together here is what? Your f of s. But whatever is in the bracket is your g of s. I hope you are okay with that.
Yes. Yes, sir.
Yes,
I'm
sir.
okay. I'm okay with this.
I beg, the name is Alphonse.
Okay, sir.
Okay, so let's apply the chain rule for this function. The chain rule said that what? You differentiate f first, right? And like I told you, all this one is what? Your f of s. So let's differentiate this one. If you differentiate this one now, it will become what? 11 into bracket 1 over 2 s exponent 4 minus 3 s squared minus s plus what? 5. The exponent 2, you do what? 11 minus 1. So you can see that what? For what is in the circle, the red one, you can see that we apply what? The power rule, which is what the power rule says that what? You take the power at the top and you multiply by what? The differential form of what? The function. So this is the power 11. We take it, we put it here, and we multiply by what? The differential form of the function, which is what? All this one, we do what? 10 minus what? 11 minus 1 will give you a 10. Now, the other part of the chain rule says that what? You have what? This one here, d prime of s. So your d prime of s, the d prime of s, the d prime of s will now be what? You differentiate whatever is inside the bracket. Don't touch the power, only what is inside the bracket. You differentiate only this one. Okay. For g of s, we are differentiating only this one. The one in the bracket, sorry, the 5 2 is part, only this one that we are differentiating. So you can see that if you differentiate it, you are getting what? This function here. Are we all okay? Please, those that are watching from YouTube, if you have any question, you can just send a message to any of the TA, then we'll get it, okay? Especially TA David. Yeah. And also you can give your comment if you are watching us from YouTube and ask question as well. You still take your mark, your bonus mark. So g of s, if you differentiate this one, you can use the power rule for this one here. Use power rule for this one. You use power rule for this one too as well here. And you use s derivative form of this one. You use what? Constant rule for this one here. So once you've done all those things, you get what? This function here. That's why I started with what? The constant rule, the power rule, and what? The sum and what? The subtraction for rules of what? Derivative. So that's how we do it. And this is what your final answer. For chain rule, we don't expect you to go too far because we know that what? The function is very big. So we don't expect you to go far. We just want you to what? Show us the first steps. And you can see that here too, the first steps has been missing here. We didn't show the first steps here. So who can give me the first steps? Who can give me the first?
Me.
The name, please.
Thelma Kufado. Hello.
Yeah, Thelma, please talk.
Okay. So since we are differentiating the equation separately, I think to differentiate the f of x, the first one, can I say I'm not differentiating the g of x, so maybe it's becoming 11 g of x raised to the power 10.
11 g of s raised to the power 10. All right.
Yes. And then now for the g of x, it becomes 2x cubed minus 6x minus 1.
Okay, you see that the first stage you said that what? 11 g of s to the power 10, right? That means that
Yes.
you are not differentiating the g of s. So the second one, you differentiate the g of s, right? The second one, after the first stage, which is the 11 g of s to the power 10, then you differentiate the second one. which is what 2x
Yes.
cubed minus 6x minus 1. Yeah,
Yeah.
you can go like that. Then the next steps, we can do what? Replace the g of x by what? Its value. But if you do it like that, you still miss my first step. My first steps, I want to see something related to this. I want to see something like this. I want to see the function to look like this. You get it? For the first steps. Are you
Okay.
getting me now? Tema?
Yeah. Yeah, I understand.
Yeah, so what I was expecting you guys to show me for first steps is that 11 into bracket, all this function, prime. You see all this function, you write all these things into big bracket, something like this. Something like this. All this one first into bracket like this. Prime. You get it? Then you multiply by what? Then you come bracket and you write all these things for me like this. You write all these things for me inside here. Then you close the bracket and you do prime again. You get it? So I was expecting something like that. Who can write it for me and give me the answer?
I can.
What's the name, please?
Kwesi Asare.
Kwesi Asare, right? Your ID, please. Kwesi Asare, your ID.
2202. 2202.
2202
51.
51
5351.
5351. Okay, 5351. 202 2202 5351.
Yes, please.
Okay. So please give me the answer, please.
Okay, so with the first step, we do f, we place the whole function, that is the into brackets half x raised to the power 4 minus 3x squared minus x plus 5 brackets closed 11, and then we place all that in brackets and then prime, and then we multiply it by what is in the bracket, that is a half x raised to the power 4 minus 3x squared minus x plus 5 also prime. And then the next step, we have the 11 open brackets half x raised to the power 4 minus 3x squared minus x plus 5 brackets close raised to the power 10. That is for the whole thing prime, multiplying the prime of gx, that is 2x raised to the power 3 minus 6x minus 1, brackets closed.
Okay, that's nice. You have your plus 5.
Okay, thank you.
Okay, you're welcome. And
Sir, please, I don't understand.
Pardon, who is
The
this?
equation, is it? Please say the equation, is it f inverse of j of s multiplying g inverse of x, or f inverse of j of x multiplying g inverse of f of x?
For the chain rule.
Yes, sir.
Okay. The chain rule, what we are just saying is that, please, can you ask your question once again? I don't want to go off board. No.
Please, I was asking that.
Yeah.
The chain rule, the formula, is it
Yeah.
f inverse of g of x
Oh, no.
multiplying g inverse of
No.
x, or f inverse of j of x multiplying g inverse of f of x?
Okay. Okay. This one is not f inverse. We'll reach there just later. You get it. Okay. It's
Okay,
f.
sir.
It's not inverse. Okay.
Okay, sir.
It's prime. This prime here is telling you that what you differentiate that function. This one is telling you differentiate. It's not inverse. I think
Okay.
when you reach the inverse form, you see the difference between the two. Okay.
Okay, sir. Thank you.
Welcome. Only. Who is Bonzi? Bonzi or Bonzi? Bonzi. Oh, sorry.
Yeah, it's me.
Okay. I think we are having challenges with the 11, right? That's why
Yes,
why not multiply through by 11?
yes. After differentiating.
Yeah. I said something like for 10 rule, because the function has what a huge power. Here you can see the power is 11, but you want to break it down and write it in another simple form. So if you multiply through by 11 right now, you see that what you have big number inside the bracket, but we want it to be simple. So that's why we factor 11 out. We leave it there like that. So this can be your final answer. Is correct, because any further movement will make the function become what? Too clouded and complicated. I hope I have answered your
Okay.
question. Okay. Any other
Yes,
person?
please.
Yes. Your name? Please, any other question? Okay. Bonzi, what is your rare ID name? I think rare ID name. What is your
ID name.
I say rare ID name.
My ID.
Yes, please.
222
222
028
028
00.
00. Okay. Noted.
Thanks.
I will have surprise mark for you later.
All right. Thanks.
Now, this is another example of chain rule. So let's try to apply it again. Who can give me the first steps? I always leave the first step. I want to see whether you guys will be following or not. So who can give me the first steps here? Who can give me the first step for 5 marks? Hello?
Hello.
Ado Bafo.
Okay, so the first step is we have to treat the s squared and the square root of 4 minus s cubed as a product. But aside treating those two as a product, the square root of 4 minus s cubed must be solved using the chain rule. So we will differentiate s squared and maintain square root of 4 minus s cubed plus the differential of 4 minus s cubed. Then we multiply by s squared. But the square root of 4 minus s cubed will be solved using the chain rule. So we represent the u by the 4 minus s cubed by u. So since it is square root, then we have y equals u raised to the power half. So y equals u power half. We solve that one using the chain rule, which is dy dx because dy du times du dx.
Mhm.
So dy du will give us 1/2 root u. Then du dx, we find the derivative of 4 minus s cubed, which is negative 3 x power 2. So that's the du dx. Then dy du is 1/2.
Okay. I see where you reach. Where you reach now, you will be able to finish. So thank you, +5.
Yes. Thank you.
Derek. Is it Derek? Sasu.
Yes, sir.
Sasu.
Yes,
Sasu.
sir.
Yeah.
Yes.
You said something that s square into bracket 4 minus s cube bracket close exponent half. That one you break the function, okay? That one you just break the function. The function y is equal to s square multiplied by square root of 4 minus s cube. That's the function that you just break. That's not the first steps. Even though it's part of the first step, you have to break it down before you move to what the other one. You get it?
Okay, I understand. Yes,
Yeah.
I understand this.
So because if you don't write it the way you've written, if we don't write it the way you've written it, we will not get what this side, the next steps. So what you've done is part of what the first steps to as well. So I'll give you +2 for it. It's incomplete.
Thank you.
That's right.
Yes, sir.
Sasu was the person say yes, that is Sasu. So your ID, please.
2204
Yes.
80
80
28.
28. Okay.
Thank you, sir.
22048028.
Yes.
And mine.
Okay, that's 3.
Thank you.
Okay, someone is asking question from YouTube. Eric. Eric is asking, please, can you represent the whole equation U? Can you represent the whole equation with U as in what y is equal to U exponent 11? Use the power rule to solve U exponent 11 to get 11U exponent 10. Then use the power rule again to solve the equation inside the brackets, then multiply. Okay, Erin, you can do it like that as well, okay? Just that if you do it like that, it make it simple for you. You can still go. Your U now has become what? Your G of S. It's still the same, so you can still do it like that. Erin. Erin, send me an email, a message on WhatsApp, okay? With your ID, send me your ID on WhatsApp. Now let's move to the next steps. Okay, now let's welcome our master. This at your level, you will be more concerned about what the implicit function form. All that we've done, that one is SHS, is Coco. You can master that one easily, but most of the question here will be in form of what implicit form for you. And sometimes they will not just ask you directly that find a differential form of this implicit function. Some will come like that to give you some additional point, but most of them can be what in form of word. For example, a car climbing something, or a car moving around a road, something. But if you don't understand the basis, which is what the normal equation, how to differentiate the normal equation form, you will not be able to understand the word form. So let's try to solve one example under what the implicit form, then we'll move to a word form function. Our example here is what? Find d of y divided by d of s for s squared y plus what? S y squared is equal to what? 6 minus y cubed. This is our function. So the question is asking you to find what? Dy ds of this function here. For implicit function, we have what? S and y inside the same function. So you can see here that we have s here, we have s here, and we have what? Y. And here too we have what? S, and we have what? Y as well, and we have what? Y here. So this is an example of what? Implicit function. How do we do this? For implicit function, the first step is that what? You multiply the whole function, all this thing. You multiply both sides by what? You multiply them by what? D divided by what? The S. You multiply both sides like that. That's what you've done for the first steps. And it's really important. You don't have to miss these first steps. It's important. Then after you multiply through, then you have to what? Start your differentiation. How do you do implicit differentiation? Take this function, for example. To differentiate this one, the first thing to do is that what? You keep your S here constant. You keep the first S constant. You can see that this is what? Your S. We keep it constant. Then you differentiate this one. That means that you multiply d over the s multiplied by what? Y. So if you multiply it, you get what? dy ds. But you keep this one as a constant, so you don't do anything to it. You can just shift it to the other side and multiply the d over ds by what? Y to get this one. Then you come again plus. Then after you do that one, the next stage is what? You keep this one to constant. You keep that one to constant. Then you differentiate what? D over what? D over ds multiplied by what? S squared. So you find what? The differential form of what? This one. So if you differentiate s squared, you get what? If you differentiate s squared, you get what? 2s squared. That's what you've written here. The differential form of what? This one will give you a 2s. Are we okay? Before you come back now, this plus is this plus, not this one here. The plus that is here is this one. So all that we've done right now is what? For this one alone. That's what we've done. So who can write the second differential form for me? Anyone to write the second differential form for me?
Yes.
Okay. Yeah, Abba. Abba.
Hello.
You want to talk, right?
Yes.
Yeah, you want to talk.
Yes, please, can you hear me?
Yeah.
Yes, please. Yes.
Yeah, I'm listening. Give me the second difference form for the equation. I'm canceling it so that you guys will not see it. The answer was there.
So there's after x squared dy dx plus 2xy, we'll
Pardon?
differentiate
Mm-hmm.
after x squared dy dx plus 2xy, we'll differentiate xy squared.
Uh-huh.
Yes, and after
And
doing
what will be the differential form for xy squared?
we'll get we'll get x into bracket 2y dy dx. Dy dx will
2y
cancel because yes, dy dx.
dy Yes.
dy dx.
Okay, let's
Yes.
see whether you are right.
Then dy dx will come there because we are differentiating y squared.
Yeah,
Yes.
you are right.
Then brackets close plus y squared is equal
Okay.
to 0 minus the 0 because we are differentiating the constant 6.
Oh, this one, yeah, you are seeing it already.
Okay. Okay.
So if you come for you are seeing it already.
No, I've
Okay,
solved it. I solved it.
Abba plus 5. Okay. So is anyone having problem with it? Any question? Frida. Frida, do you want to ask a question?
No, sir.
Okay. Then let's continue. So that's it. The second form now is what? You have S, you keep S constant because the first one you keep what? S square constant. But the second one now, you are doing the other one. So you do the other one to the same way. You keep S constant and you differentiate the other one. Pardon?
Question.
Yeah, question, Nira.
Yes.
And
So
Nishira.
please, so that means with differentiating the x squared y plus xy squared, we are using product rule for the both of them.
Yeah, it's implicit form, but you do it in form of what? Product rule. If you can see here, this one that we've written here, this one, when we are doing it, if you can see where is what all this thing here, but at the middle is what plus. So we use product rule because you have one function here, s, and you have another function y. So it's product rule. You differentiate this one first and you multiply by this, then plus you differentiate this one, you multiply by this the same way. That's how we do it.
Okay.
So that's how we do it. Did you get it now?
Yes, please.
Okay. And hey, they named the Faidu on YouTube, please. He gave the answer that s multiplied by 2y dy ds plus 5. Yeah, you are giving all the answer here, y squared. So I don't actually know your ID. I don't know whether the name that you've given is the correct name. But if you are listening to me right now, you can text me on WhatsApp, okay? Or you type your ID there so that you can see it. Any other question? Okay, I think I have a question here. Me too. There's no question. If there's no question, then we can move. So now let's solve another example. Let's solve this example. Are we all there? And I will plead you guys to pay much attention here because this is the format which questions will be coming for you guys in what implicit form. Even though the other one will come, but this ones will carry big marks. So if you're able to break down this one, you'll be able to get what more marks. So let's try to solve this one and have overview of what how the implicit function work. Uh, the lecturer also will come. I think today the lecturer will help you with it as well. So today we are coming to do it, but one thing is that what if you pass through right now before the lecturer is doing it, you have what an idea of whatever is ongoing. Then you catch it faster than if you didn't know anything concerning it at all. Are we okay?
Yes.
Yes.
Okay, the question says a 10 feet ladder is leaning against a house on flat ground. The house is to the left of the ladder. The base of the ladder starts to slide away from the house when the base has slid towards 8 feet from the house. It is moving horizontally at the rate of what? 2 feet per second. How fast the ladder stops sliding down the wall when the base is 8 feet from the house? Hey, my English je wahala. I like numbers. I don't like English math, so bear with me, I beg. But if someone can read it for us there with a sweet voice or a bass tone voice, that would be very nice. Samsung, do you want to read it for us? I want a lady voice.
Okay, so first,
Yeah, Frida.
can
I want
I read?
lady voice.
A
You want
10 feet ladder is leaning against a house on flat ground. The ground is to the left side of the ladder. The base of the ladder starts to slide away from the house. When the base has slid to 8 feet from the house, it is moving horizontally at a rate of 2 feet per second. How fast is the ladder stop sliding down the wall when the base is 8 feet from the house?
Thank you. At least everyone's here has stopped something this morning. Okay, now let's try to break down this question, okay? They said that you have a ladder against a wall, ladder or whatever, ladder against a wall. So that wall, imagine that you have a wall, some horizontal line. Take your wall like what? Some horizontal line. Sorry for that. So imagine that you have the wall in a vertical line. Then your ladder is what? Something like inclined to it, like the way they've said it here, that is against the wall. We all know how we put ladder to a wall. If you want to do something at the top, you have been seeing your electricians and plumber and co have been using their ladder against the wall. You can see that what is inclined. So imagine something like that your ladder is another line that is inclined to the wall. And now they are telling you that what you have what? Horizontal ground. So you just imagine the ground to be what? Horizontal with the ladder. So you have something like what? Right angle triangle, something like this. Something like this. Are we okay? You have something like right angle triangle. Now, the next thing to do is that you have to identify the terms given to you. So they said that the ladder is what? 10 feet. So this is our 10 feet. This is the ladder here. This one here is what? Your ladder. This is your ladder. David, be careful. This is your ladder. So they say it's 10 feet. So it's against the wall. And this is what? The house. This is what? The house. You get it now? And this is what? Your ground. So now the next thing to do is that what? The next thing is that they are telling you that what? The ladder is sliding down. So you can see that what? The next thing is what? Is sliding down and moving what? Since it will be sliding down against the house, then the ground floor will be moving backwards. So that thing should be telling you something. But if it were to be moving up, it would be the other way around. But here is moving downwards. That means that the horizontal line that we have here now, something will be happening. So keep it in mind that something is happening there, that your answer will be related to it. Okay? I mean this one. Why that this arrow, this side here is what sliding down. This one is sliding down here. So it's moving away. So why is it like that? We'll see all those things. And this one, too, since it's coming down, it will give us a clue about some kind of change later. So now let's try to put our values inside the diagram. So here they said that what we have 8 feet. The ladder is what? Sliding down at 8 feet sliding down. So this is our 8 feet. If you have exercises here and the thing is moving away 2 feet, it has been given in the question. So moving away like this 2 feet and coming down 2 feet. So you represent all those values inside your diagram. One thing about this place is that you have to show your question in diagram form. Don't just start solving the question. Try to put down your diagram. Put your data inside the diagram. That one to take some marks. So try to put everything in a diagram form that will look nice. Okay. Then the next thing we know that we are giving the S dt, which is equal to 2 feet per second. The S dt. Here we are having our S, here is our Y, but this thing is moving according to time. Imagine that you going to your house. If you are walking from your place to a certain place, you cover a distance. That distance that you cover that distance with respect to a time. If you move from your hostel to the engineering school, you cover a time. If you move from you move from, let's say, engineering school to your canteen or anywhere, that one to you cover a distance with respect to time. So if you go back to the question, you see that they're giving us the rate at which the ladder is moving, sliding down, is moving horizontally. They say the ladder is moving horizontally 2 feet. So you see the 2 feet per second here, since the T is moving horizontally. That's why we have our 2 feet here. The arrow is showing that the T is moving here 2 feet. And now the question is giving us again that the thing at the top, when the base has slide to 8 feet, that means that the thing slide down 8 feet. So that 8 feet, that one you represent it in the diagram, which is the 8 feet that we've written here. You get it? Because someone has written someone that 18 feet. That's why I'm putting more attention into that here. They say 8 feet. So now we are giving the two value. We know our ds. We know our ds dt. And we want to find dy dt. Because you know the s dt, but they are asking you dy dt. So we need to relate between dy dt and the s dt. So you have your ds dt at the horizontal side, but the top here, because the top is your y-axis, then you have dy dt there. Because if the thing is moving downwards, that one too is occupying a distance, and the distance that is occupying is respect to time. So the horizontal line here will give you this side will give you dy dt, and this side will give you the s dt. Are we all okay?
Yes, sir.
Yes, sir.
Yeah. I know.
Yeah.
Now, let's try to solve the question. Since we know our ds dt and we know our dy dt, that is here, we have to use what? Pythagoras theorem. You get it? But by using that theorem, you know that what? Anything Pythagoras or whatever. David, be careful. I will throw you outside now. So since we know that they are acting as dy dt, if you use that theorem, you see that what? The ladder here square will be what? Y square plus what? S square, just like the way we used to play with it in SHS. To find the hypotenuse here, it will be what? Hypotenuse is square will be equal to what? Y square here and what? S square. Are we okay? So this is what I've done here. This is what here. Yes. This is what I've done here. You can see that they said the ladder is what? 10 feet. So the ladder is 10 feet. So since it's 10 feet, if you want to find this one by using what? The theorem, you have what? Y square plus S square is equal to what? 10 square. That's what I've written here. Are we all okay? So now, this one gives you what? Your first relation. But that's not the end. Now, after reaching that one, you move on. You have to find what? You have to differentiate that function. The function that you just write by applying your equation, this function that you just wrote. You have to differentiate it by using what? Since it contains what? S and Y is what? Implicit function. So we have to use what? Your implicit differentiation knowledge to differentiate it. So we all know that if you want to use your implicit differentiation, you have to multiply through by what? D over what? Dt. Since we are trying to find what? Dy dt, then we have to multiply by what? D dt. Because here we are doing it with respect to time. Remember, we are doing it with respect to time, not with respect to s. The example we saw previously was what? With respect to s, but here we are doing our derivative in terms of what? Time, because the team is moving against time. All right. So now if you apply, I wanted someone to give me this thing before, but anyway, it has passed. I've shown it already. So let me see. Is that someone is asking question here? Please answer that question too. Okay. Abdul. Okay. So now you apply the implicit rules here. Once you apply the implicit rules here, you have what? D divided by dt of this function. You multiply d over dt by this function here. This one. Okay. Eric. Eric is asking question. Please, when you are given a quotient rule question, can you multiply through and solve it as implicit function? No. If it's quotient rule, it's quotient rule. You cannot multiply through and do this thing, because the question will be asked like, use quotient rule to solve this. Use implicit differentiation to solve this. Use what? Chain rule. Use what? Product rule. The moment you hear those things, make sure that you stick to the rule. Don't use your own knowledge. We all know that you can differentiate the function easily. They know that, but they want to see how you can apply the rules. That's why the rules are there. So now let's talk about our function. So here we are just multiplying through by what? D over what? dt. So this one is this. This one too will give you what? This one. Then this one too, you have what? This one here. So you can see that what? Here, if you differentiate what? A constant, d over dt of a constant. This one is a constant. If you differentiate a constant, is 0. But here we have what? D over dt over multiplied by what? Y squared. So you have to differentiate this one in terms of what? Time. So you have what? 2y squared multiplied by what? dy dt. Because you differentiate y with respect to time. That's what we are telling you here. You differentiate this function y function in terms of t. And this one to do it, if you differentiate this one, you have 2s ds over dt. Because this function is s function, you differentiate s function with respect to what? Time. Now, the next stage is that you just have to what? Rewrite your equation. Because you have 2 here and you have 2 here, you just have to do what? Divide through by what? 2. If you divide through by what? 2, for example, you see that what? You have what? 2 over what? 2 here, and you have another 2 over what? 2 equal to what? 0 over what? 2. So 0 over 2 is what? This one will still be what? 0. So this one will cancel out. This one will cancel out. Then you have, that's how come they have what? S ds dt plus what? Y ds dt is equal to 0 here. Are we all okay?
Yes.
Okay. Now we find our implicit function, which is what? Equal to this. The one we just solved right now, that's what is here, which is equal to this. Now we have to solve the question that they are asking now. Now we are giving what? The s dt. So we are giving what? We are giving this thing. You will be giving this one, which is called to what? This one here. You get it? And they are asking us to find this one, dy dt. This one, we don't know it. We don't know dy dt, but we know the s dt. So the only thing remaining now is what? You put the s dt inside the equation and you make what? Dy dt the subject. Then you make s the subject and that's all, right? Are we all okay? Are we all okay? And also, they've given us our s as well. This s here, they've given us the s2 as well, which is called well, this one here. Are we okay now? So someone should make y dt the subject for me by putting in the value and give me the final answer.
Okay, so dy dt.
Yeah, make dy dt the subject, okay?
Dy dt equals negative 8/3 feet per second.
Dy dt is equal to what?
Negative 8/3 feet per second.
Minus 2.66 feet per second.
The person that is talking first, who is talking first?
Kwesi
The person
Asare.
that was Kwesi Asare, you again. I see. You said minus 8 over what?
On 3 feet per second.
On 2 feet per second. Okay. The lady that was talking, your name, please.
Thelma.
Thelma. Okay. Thelma. Okay. Thelma, what, please?
Akufo-Addo.
Akufo-Addo. Hey. Okay, we'll talk about that one later. Okay. Another one. Tell my
I was
answer was
saying
what?
minus 2.667 feet per second.
Okay, you've done it feet per second. So because I think 8 divided by 3 will give you 2 point something something. Okay, that one too. Okay. So that plus 5, I will share it between the two of you. Okay. Plus 2, 5 plus 2, 5.
Okay.
Okay.
All right. So the next is, that's what they were giving us, that once you know the value of that, sorry. Yeah, this is it. So once you put the value inside, you get something like this. That's the answer that they've given. Are we all okay? Now,
Yeah.
now that you know your dy dt, which is got to what, 8 of this. So what will be what your y then? How can you find your y? Who can find y for me? Who can find y for me?
Y equals 6.
How did you get it? Because 6 is showing there, so you know,
Using
right?
the equation x squared plus y squared equals 10 squared. We have our x
Okay.
to be 8. So you substitute 8 into it, and then you get y squared equals 36. So then y equals 6.
Hey, Kwesi Asare, today dear, you dey chase Marco. The quiz wasn't good for you all.
Hey, no.
We've not shared it yet. Don't worry, I will check it later. Okay. You get additional points.
Thank you.
Welcome. So what he said is this. You just, since you know that S is equal to 8, then you use the equation that you got to find what y. You make y the subject and you get what? The 6 feet here. That's what he has done, sorry. So now, that's basically how we solve it. The question that they were asking you, they just asked you to find what? Dy dt, how it's sliding down. So anytime you are giving the question like that, make sure that what? You read the question first, you try to draw the diagram, you put in the data, then you do what? You find whatever they are asking you, okay? But there is some kind of thing that you must put into place. The answer we got, like I said from the beginning, that you should put attention to the arrow, right? The negative value indicates that what? The top of the ladder is what? Sliding down the wall. In what? The negative direction, yes or no?
Yes.
Yeah, you can see here. The thing is sliding down in the negative direction. So that one should tell you something. Then the next one is what? Oh shit. Dave, can you see my screen? Oh. So that's what we are, the negative value, because we got what? Negative 8/3, right? So the negative side is because of what? The negative direction at which the ladder is sliding down. But in other questions, they can give you the answer, that value of what? Y. You can get, if you get the value of y, or the s value in what? The s was going into the positive direction. So if you are using what? Word-based homework system, and the question asks at what rate, this is the statement. The moment you see what? At what rate does the ladder slide down the wall? You see this one, they take account of what? The negative value. So keep this in mind. The moment you see this statement in the question, that means that what your answer should be in a positive form because they take account into what the negative value already. Are we okay? Hello, are we okay?
Yeah, we are okay.
Yeah, we are okay.
All right. So basically, that's what I have for. Hey, there's some questions here. Let's check. Okay, that was from Tema. Tema, I've seen your answer. Okay. Any question on YouTube? Okay. So basically, that's how we do it. But I want to introduce you guys to another form of what differentiation. Let's talk about this thing. Give me a minute. I want to stop sharing and share another slide. Okay. I think we have about 10 minutes remaining for us. So yeah. Okay. Yep. Okay. Let me. Yeah. I think it's the article. Yes. I hope everyone can see my screen.
So we see.
Okay, okay.
Please give us a moment to be right back.
I hope you can see my screen now.
One man salary. Who said one man salary? It was like 1 month salary.
Make sure you say again. Okay, let's talk about what exponential function. Okay, I remember I gave you guys some example last time like this, something like this. Find the limit of this function. If you can remember, I gave you something like this. So this is how you do it. You use the formula like this. If limit of as plus h minus as is equal to 0, you just have to apply this formula. Yeah. You apply them to find the limit. Anytime something has been given to you like that. So keep this formula in your head. If you are sleeping and wake up, it should be in your mind. You wake up with it. Now, let's look at another form of differential function. Okay. Let's look at this form. Logarithm or exponential function. Let's talk about exponential function. Anytime you have a function e exponent something, e exponent s is equal to what? E exponent s. Someone will ask, how do we do it? The thing is that anytime you are differentiating what exponent function, you do this thing. You differentiate whatever is at the top. If you can see my screen, f prime of what? E exponent of s. You take the exponents, you differentiate and you multiply by s. So if you do it this way, oops. So this is the formula. This is what they did to get what? This one. This is what they did to get this one. So you differentiate the top and you multiply by the function itself. So if you differentiate s, you get what? 1. This one like this will give you what? 1. And you multiply 1 times e exponent s is equal to what? E exponent s. Now, what of what? Logarithm function. This one too is simple. This is the formula to use for what? Logarithm function. You get it? But this one, let's say this one is not good. This is the formula for logarithm function. Anytime you have what? Ln s, this is the function inside the bracket. They said differentiate this function. So how do we differentiate this function? The formula said that what? To differentiate this function is equal to what? 1 divided by what? Ln b multiplied by what? 1 over s. And how do we do it? Ln s ln s, for example, is equal to what? You differentiate the top. You differentiate whatever is in front of what? Ln or log prime divided by what? The function itself, whatever is at the in front of what? The s. So is what? S. Are we all okay? So if you differentiate whatever is in top of what? Ln, you get what? S. If you differentiate s, you get what? 1. You get it? And if you differentiate what? S, you get 1, then this one will become what? S. So you can see that what? We have S here. That's why we are doing it like this. Prime. That's what we are dealing with. The lane, we are not much concerned about it when we are doing the differentiation, but whatever is in front, that's what to focus on. Now, Gerard, I'm not the book that I'm using here is from research. I don't have time to read books, so I read different books. So I can't give you one, but if you need any book, you can come and see. I'll give you one book to go and read. And also, Tia David is selling some pamphlets. It's really nice. So if you have money, you can come and buy it. There are nice questions that if you solve those questions, I bet you break calculus ground floor. You get it. So the price is 60 Ghana. So the price for the booklet is what 60 Ghana. And those that has paid, they can come for their own. Okay. If you know that you've paid for it, come for it. But if you have not paid, wahala for you. So now let's talk about what another one. Let's look at this example. We have what? They say calculate dy ds of what? Y is equal to what? Log 5 of s. Log 5 of s. This, they said dy ds because you have y is equal to, this is your function, y is your function, and whatever is here is what? With respect to s. So how do we find it? You have to find what? You differentiate whatever is at the top divided by what? Whatever is at the ground. You get it? So 1 over what? Ln 5 multiplied by what? 1 over what? S. If you take whatever you differentiate this one, you get what? 1. Something like this. If you differentiate here, you differentiate this one. This S is equal to this. And this one is what? S prime. Then this one, you find what? 1 over what? Ln 5. Why is it that is ln 5? You see this small 5 here. This small 5, that's what is giving you here. So anytime that you have log base something, so if that side were to be what? Base 6, this place will be 6. If it's base 10, then you have what? Ln what? 10. So if you do it, well, that's why normally if you have just log, you don't normally write this one. So you can put it in your calculator and see the answer that you get. Now, the second example, who can solve the second example for me? Who can solve the second example? S square minus y square. Okay. Who is there?
Yeah. What question are we solving?
Hello?
Yeah, I'm asking what question are we solving? You said we
The
should
B.
I
Who
can't
can
see.
solve the B? You can't
Is
see.
the one with the link?
Yeah, the one with the link. This one.
Okay.
B is equal to ln sy is equal to s square minus y square.
Okay, okay.
Pardon?
Okay.
Someone with the short say, okay, she employ people.
Please, I'm done. Hello.
Hey, your answer before we close. Who is talking?
Lenovo. Lenovo.
Pardon? Lenovo. Okay, Lenovo. Okay, I've seen you.
Okay, so please, should I give my answer?
Yeah, give me your process and the final answer.
Okay, so you first differentiate each term. So the len bracket open xy, you differentiate it separately. The x squared, you differentiate it separately, and y squared too separately. So
okay,
you get something like x dy dx plus y all over xy is equal to 2x minus 2y dy dx.
2x minus 2y
Y dx.
dy dx.
Yes.
Okay. Are you sure you didn't jump any steps?
No.
The first step, how do you get to what? S dy dx plus y divided by sy.
Please, you stated that when differentiating len, maybe when you have len x and you want to differentiate it, you get something like x prime divided by x.
Yeah.
So this one you had len xy. So you get something like xy prime all over xy. So the xy prime will give you the x dy dx plus y.
Actually, you've missed a kind of steps, but anyway, the answer you gave is correct though. But you've missed steps. So you said Lenovo, right?
Yes, please.
Okay. So go back. If you see this one, you do it what? This is SY, you do it like a product one. That's what you've done. It's correct here. But here you have what? ds square divided by what? ds, right? So you differentiate to be what? 2s ds over what? ds. That will cancel out. That's why you have 2s. Then what will happen to this one? It will have what? 2y dy ds. But the steps that I'm saying you are missing is that how do we write this one? What is the law? You have to show the prime. You get it?
Okay.
So you show the prime so that you know that you are using this type of equation for it. This is how you got it. You get it?
Okay.
At this one, if someone see the person that you know, the person will know that you differentiate it. But how the person will know that you differentiate? So put bracket and you put your prime at the right place. Okay?
Okay.
Plus 5. Tia David said that some lady gave her a sanitizer yesterday. So be careful there. So the lady that gave her the sanitizer should come and see her for something. Okay. Okay, so I think we'll end it here today. So after that, no, you just make what dy ds the subject, okay? In the equation here, once you've done it like the way Lenovo laptop name, people use them like name. Hey, you people will kill us. So after you've done this one, like he has said, you just make what dy the subject. So before you make dy the subject, you need to expand what this equation here. You have to expand it. You expand. You have to expand this equation here. So once you expand this equation, then you can cancel this out and you make what dy ds the subject.
Class, right? Looking at me.
No, I was looking at some guy. So after that, you just simplify and make the y the s the subject, and you get your final answer. So, any question?
No, sir.
Okay. So, okay. Someone is asking a question that what if you are not told to use chain rule or to use quotient rule? What do you have to do? That one they not tell you anything. You can use any of the rules to differentiate it. But the moment the question tells you that you use quotient rule, make sure you use quotient rule. If they say use chain rule, use chain rule. Don't create your own thing. But if they've not tell you to use any of the rules, you can do anything. You can do it directly. You can do how. What matters for that one is that you get the correct answer. But the moment you hear that use this rule, then make sure you attach to it. Okay. If there's no question, I think we'll end it here today, so that we all will get rest for the class later, and we will see what's next. Okay. You can end the meeting. Okay.
Okay, so I believe you are in session. I mean, you got something from it. Anyone didn't really get anything from this section? Okay, so far as everybody is quiet, then that means we're successful with our tutorial, and then we'll see you in class later 1:30 today. Have a good day. Thanks for joining. Bye.
Thank you too.